are able to listen the network. And something more interesting, usually in monitor mode, you're also able to inject packets, so to build your own packets and do some interesting things. You have different channels, different SSID, BSSID, SSID, I think you all know about this. Different frames, we will explain, well, we will use some of those frames in order to simulate some fake AP, fake access point, or all this kind of things. So we will send some authentication frame, association frame, beacon frame. We will introduce all of this later when we will present the tools. Something very interesting also in Wi-Fi 802.11, you have some management frame and control frames. Control frames will be very interesting also, especially the acknowledgement frame, because this is something important in Wi-Fi in order to acknowledge when you transmit data, and this is some very key points if you want to be able to inject raw data. Very, very quickly, we will mostly use those tools. So you will see some hyperreal capture. We will use the tool to show you some frame. So I guess also you all know and use hopefully this tool because it's very useful. Very quick example, but you will see live demo very soon. A few reminder, thanks to Mike who is in the room, extracted from one of his presentation, Stumbler, Sniffer. We will also use some of those tools. Basically, we will use some sniffers like Kismet, sniffers that will be able to detect different packets on the Wi-Fi network, and stumblers that will use the card and try to probe for new networks. So very, very quickly also, NetStumbler, I think you are all aware about this tool, very useful under Windows or also on Pocket PC. I will try also to make a small demo with some Pocket PC trying to find some network. So you recognize the screen. Kismet, I think that Mike could speak a lot about this tool. Very, very cool tool. So I have a very quick screenshot. So why do you want to use those tools? Well, you can want to do some war driving, and we will explain more about this and what you can do sometime, or new idea to protect yourself against people trying to war drive your network. For example, by sending hundreds or thousands of, by simulating thousands of fake access points, and try to make those access points very real, which means that it will be very, very difficult to detect that those access points are fake access points. They will really behave like real access points, and we will explain this more in details later. So some of these pictures will be familiar to you, extracted from different presentations on the web. Some people with some nice antenna. I also see that just over there are some people selling nice Yagi antenna, very useful to do some war driving. You should also recognize some people from Shmoo here, presenting some stuff, some war driving robots and all this kind of thing in our conference last year. Or Yagi antenna, all different way to use, well, all different tools to be able to do some war driving.
Just after this little presentation of Wi-Fi, kind of Wi-Fi tutorial, first of all, before to begin the next slides, we must have a definition of what is a rogue access point, because we will employ this definition load. It is a wireless access point that has been installed on a secure company network without explicit authorization from a local network management. Last year, when we talked about Wi-Fi IDS, we explained some means to discover rogue access point, like having ACL with whitelist BSSID, and trying to search if these access points are interconnected to the local network by associating to them, by seeking MAC switch tables and so on. So this is very a key feature which is generally implemented in wireless IDS, which are specific tools to analyze the radio, the last 2 frames, and to do something more interesting about rogue access point to locate themselves in the area of the enterprise, for example. There wasn't any definition of fake access points in the Wikipedia, so in bad English it will be an illegitimate wireless access point which objective is to fool users. Effectively, it is a kind of attack which is quite basic, but can be very devastating in when connecting to wireless hotspot. And for wireless IDS, it can be really a nightmare, and we will describe it later. Some words about raw injection, because all the tools which will be presented in the next slides are using the raw injection. We really mean about layer 2 frame injection. That is to say, we could send .11 management frames, control and data frames. And it could be very extremely powerful because you manage all the association process, the authentication process, and so on. And you could be a very, you could design some very powerful tools. 2 years or 3 years ago, it wasn't really easy to do this because some frameworks were managing some fields, some .11 fields, like the fragmentation field, like the sequence number field, like the BSS timestamp field. And now with some recent drivers and firmwares, you are able to modify some parts of the .11 frames, like the BSS timestamp, which will be very interesting when forging some beacon frames or probe response frames. So in fact, your goal is to inject any frame you will design. Just for example, we have some wireless card that we have Prism 54, which is able to inject data, the wireless frames, an Atheros card also. We have an OSTP, that is to say Prism 2.5 card. They are all able to inject frames, and we didn't test the real tech and the writing, but it should be also possible. So in fact, what are the main operations to inject frames? You create a frame thanks to a framework or by hand, and you use a socket, and you use the interface in mode monitor when it is up, and you inject it into the socket. So it should be okay. Raw injection should be used also by wireless IDS in order to implement countermeasures. When a wireless IDS detects rogue access point, it is able to dissociate all the clients that are associating to this rogue access point. It is mainly used by, performed by the authentication and the association flow. And we will talk about a new option for wireless IDS we have investigated in order to catch wireless clients. But also it could be used for an infinite possibilities of things, web cracking speedup, denial service, fake access point, and so on. So it is very powerful. When we remind of our presentation of wireless IDS last year, the tools we have designed were designed in this objective, that is to say, raw injection is a good means to inject a fake, arbitrary, and unuseful data in order to fool wireless IDS. All the data is mastered by the attacker, so raw injection can flood the database, the correlation, and detect the aggregation engines that are implemented in WiSIDS by analyzing unuseful data, and of course also flooding the GUI and the system administrator also. So it is a major challenge now, since 2 or 3 years, for any wireless IDS vendor to implement some techniques in order to mitigate this new arrival of raw injection that is very useful now. Perhaps some words about the first tool, which is an enhanced fake access point. So perhaps you may have some words of the history, that is to say fakeap.pl, which was coded in 2002, I think, I don't remember well, which is basically a Perl script using iwconfig and ifconfig in order to change the configuration of a wireless card in master mode, if you remember yourself of the 101 by Frank. So you feed it with ESSID and BSSID, channel, web, capabilities, and T-Explorer, and you have a load of new fake access points that are in fact real access points, but they are switched every time. Okay.
Yeah, the idea is to, of course, using this tool, the idea is to generate hundreds of new access points very, very quickly. And so if you are using basic monitoring tool, you will detect that you have many access point, and it's very difficult, of course, to find the real access point and to know which one is the real one or the fake one.
Yeah, and it can be mitigated by any analysis on this specific tool. All the BSSID are randomized and not cyclic. That is to say, you have a new access points appearing during the time period of the attack. So if you keep only those that are speaking, you can flush your tables and only keep those that are currently speaking. Also, as the wireless card is in master mode, all fields are mastered by the driver and firmware, that is to say sequence number, BSS timestamp, and supported capabilities like the target parameters that are including crypto protocol capabilities like WDR, RSN, etc., or radio capabilities like .11b, G, data rates, etc. So all these target parameters and fields are mastered by the driver and firmware. That is to say, fakeap.pl could be easily detected by, of course, a load of ESSID and BSSID. So sometimes there is funny ones. I remember last year some advertisement during the wireless IDS session. Resetted BSS timestamp by an idea of Joshua in order to mitigate fakeap.pl by analyzing the BSS timestamp, which is mastered by the driver, and we have a flood of low BSS timestamp during a short period of time with different sources, and can be correlated in a fakeap.pl attack, or only this. So.
Maybe you could just spend a minute talking about what the BSS timestamp is for, so people understand.
Okay. BSS timestamp is a specific field which is encoded in 64 bits, which is in fact a kind of uptime of the access point, of uptime of the last modification of the access point. So when you take down the interface or take up the interface, you have the BSS timestamp, which is initialized to a certain value. And in most firmwares, most drivers, like the heteros, this field is set to 0. That is to say, at every time the access point is sending a beacon or probe response, the BSS timestamp is updated to the time, to the current time, in fact, since the last modification on the access point.
Maybe you can show here and.
Yeah, sure.
So here
Yes.
it's an example of fake AP. If you are running ethereal and try to catch someone using fake AP on your network, you can get different frames. And here you see the 802.11 header. Maybe you can show what you are talking about, the timestamp.
Timestamp is here. It's encoded in 54 bits.
Use the mic. Yeah.
It is encoded in 64 bits. And as you may see, it's very low because it is microseconds. So if you've converted this, it is very low. And if you take another, this one should be a real access point because the BSS timestamp is very high. And if we switch to the next frame, this is another access point with a different MAC address, and it should be also different SSID, I think, airport, and the last one is also airport. But the timestamp is also very low. So you should be able to detect fake access point used by fake IP.pl thanks to this technique in order to select only the frames that are interested to analyze and to switch off the frames that are not interesting to analyze and to correlate them into fake IP.pl attack. And that's it. In your GUI, it should be okay to see fake IP and nothing else. So this is, yeah, the feature.
Okay.
Yeah. At the beginning of the attack, sequence number should be set to 0 in some frameworks, so it could be also interesting, but not as interesting that resetted BSS timestamps. And of course, the last one could be very interesting because you have the same capabilities of the wireless card because this is a unique wireless card that is sending beacons or probe response. Okay, you have a unique wireless card that is simulating thousands of access points. So you have the same target parameters for one unique wireless card with different BSS ID with low BSS timestamps. It could be another technique in order to correlate them and to have a better signature, in fact, because it's not a signature in terms of packet matching, but a signature of the attack.
Okay, so all of this is of course because fake AP.pl is running in master mode, so you are not able to tune all the parameters that are set by the driver itself. So we introduce a raw injection, and of course the idea now is to say, well, can we do the same thing but in monitor mode? So we will be able to set all the parameters and also of course set the timestamp and all this kind of thing in order to simulate a real, well, a fake, but we will really looks like a real access point. And this is what we will show now.
Just an important notice before to speak about this. We will present 3 tools. The first one is raw fake IP, that is a kind of enhanced fake IP that is using raw injection. The second one is a kind of tool that try to catch wireless clients that are searching for access points. And the last one is covert channel tool, which is very basic, but in order to show that using a covert channel wireless could be very easy and feasible. These tools were developed for wireless IDS testing for proof of concept purposes and also to show how raw injection can be very powerful and a bit for fun also. This tool will be released under the Java license. There's only the first one which is released at this time. There is the location, the HTTP location at the reference of these slides.
We need to check with the organizer if we can put all the tool on the CD, or
Yeah.
we will see, because they are all available.
So, excuse me?
Only one right now is available online.
Yeah.
You get the URL
The
at
first
the end
one.
of the presentation, and the two other one, just come here and we'll give them to you at the end of the conference if you want, or we will try to put them on the CD.
Yeah, yeah. So, what is raw fake access point? It's just a program that emulates .11 access points, but with only probe response and beacon frames, because we only want to fool wireless IDS or to fool stumblers, sniffers. Only this. This is not a virtual access point. So it could be detected by any non-novice war driver. So features. The main important feature is to try to forge coherent sequence number and BSS timestamp. That is to say, max spoofing detection, you can use sequence number, BSS timestamp. You could use BSS timestamp to detect also fake access points, fake IP.pl in the later slides. We try to have coherent time between beacons. And we try to support multiple crypto protocols just by filling some fields in the target parameters. That's really basic. So it should not be detected as a fake IP.pl attack. It should test your wireless IDS by signing some garbage data, by signing invalid characters, by a high number of access points also. So it could be very hard for wireless IDS to manage this kind of attack. And of course, it could hide your real networks to a wide device. Perhaps it could be a countermeasure activated by wireless IDS. Why not?
We could always imagine that if you detect that someone is war driving your network, you just start some tool like this and you give him 100 or 1,000 of different access points. So he will be very happy with this 1,000 of new access points.
Yeah, sure. Because we some wireless IDS are able to detect like some tools like Nest Tumbler, because they are sending some probe requests with a signature, so it could be detected as Nest Tumbler signature, and you should be able to activate a countermeasure adapted to war driving, for example. There is only two modes. The first mode is beacon mode, just creating frames and sending beacons. That's the only thing. And the probe response mode is just an enhanced mode in order to fool active scanners. An active scanner is I take a look at all probe requests to the null SSID, that is to say every SSID in fact, and I elect the access points that are virtual in order to answer with probe response adapted to the channel, and so on. So
we will try to make a demo, so using, for example, Kismet, and using also Nest Tumbler or the wireless tool that are included inside Microsoft Windows XP, for example, the Windows 0 configuration, and you will see that, for example, using probe response, we are also able to flood Windows XP and sending like hundreds of access points.
yeah. So this is the command line at first, so we could see it when you will download it. It's a proof of concept release, very bad coded, non-threaded, monolithic, etc. But it is only a proof of concept.
It runs under Linux?
Yeah, it runs on any wireless card that is able to inject wireless frames. That is to say, Atheros card, Prims 54, that are the main wireless card, main chipsets, and I didn't test it with host IP, but it should be okay for beacons, but not for probe response. I think I don't remember well. Perhaps a live demo now.
Okay. Tu attends de le lancer? Bah, je me lance un peu. C'est bon. So here you have the regular network that should be in this room, and we'll try how you can see that it just starts sending some garbage.
Yeah.
So it takes a few seconds to generate different access points. We are doing some frequency hopping to generate.
Activated frequency hopping, yeah. No, it's good now. Should be okay.
So here we randomize the SSID. We use all the available different characters that could be used inside the SSID name, but of course we could also feed the tool with a file with regular normal SSID that doesn't look so weird, because here of course if you're looking this you will very quickly recognize the fake access point and the real access point. It will be much more funny to use like the top 500 SSID name, and so you fool very easily people. So we can do almost the same thing using the Windows 0 configuration. We can check what my Windows system is finding, what kind of network is able to detect.
It is used in a probe response mode. That is to say, it is currently listening for probe requests, and this tool, Nestambler, is sending probe requests in order to find wireless networks. So we only listen to probe requests and send probe response according to the channel we are currently listening and to the channel we have created access point on.
You can see here that all the access points that are created are still alive. If we were using a fake AP, an access point will appear and then stop transmitting things. Here, all the access points are still alive because our tool is managing all the different access points in parallel. Yeah.
Are you generating random BSS IDs?
Yeah.
You're not using a valid OUI list for BSS ID prefixes?
Only prefixes, and the later 3 bytes are randomized, and the other option is to randomize everything.
And then how is Nestambler here, and I don't use Nestambler, so maybe somebody can tell me how it works, but how is Nestambler identifying those BSS, those MAC addresses as fake?
I think it is by the BSS ID, I think.
Oh, okay.
But I'm not really sure, but I think it is the case, but it should be confirmed by Nestambler also.
Yes?
You said you could use this as defense against somebody trying to probe your network.
Yeah.
But wouldn't it cause all your clients to dissociate from your network?
We are not sending this association frame here. We are just sending some wrong access point. So your client, which are already associated to the access point, have no reason to change and pick another access point.
Yeah, but a lot of times the client software just, for whatever reason, just jumps over to other access points.
So,
With automatic association, yes, but we only manage probe response. So we do not manage authentication and association, but to say the fact to go from state 1 to state 2 and to state 3. It is not a virtual access point, so we cannot associate to this. It's only probe response, not a thing.
So again,
When I see a probe request, I send probe response. That's only the thing which is.
So again, here you can see that my Windows client is reporting like a very weird access point, and I'm able also to fool the basic Windows tool.
Perhaps a little switch to Linux in order to show Kismet.
Yeah.
Yeah.
Yes.
Why neglect 802A? Because I've heard the excuse, oh, it's too expensive. But you know what? If somebody wants something, it's not expensive.
So you're asking why we're not supporting 802.A? Well, I think that the code is okay, so we can use this tool for 802.11a, B, G. We are mostly using B and G, at least in France. We don't see A very often, except on conference where there are people all over the world, but I don't think we're using a lot of A network in France.
Yeah.
But the idea is the same, and we could use.
You don't know anybody's using it.
No, I think I've never seen A network except on conference in France.
One of the arguments when FakeAP came out was that security by obscurity obviously is a difficult task to undertake. But if somebody drives past that and they're seeing this data, they're going to be more curious if they're skilled to know what you're hiding as opposed to what you're actually doing. I mean, I understand it's to stop the honest guy, but isn't this actually helping somebody that's trying to attack you?
Could be, yeah. That's a good remark, but well, you can still use the tool to test your wireless ideas.
But
Yeah.
what do you see as changes that could be made to this to make that not necessarily the case? Is there another way that you could obscure this so that it would be less obvious? I mean, can you toggle this down to like 3 or 4 extra access points?
Yeah.
Okay.
Yeah, we can give as an input file the SSID name and just simulate like 5 different access points with real name, and that will be.
We have some option in order to send using an ESSID file, selecting all the ESSID, and we have also a BSSID file, but only with prefixes for the OUI.
Can your tool be, can you use it to say create a certain fixed number of fake APs, or is it just randomly spew out as many as it can?
No, it's in fact the operation is to I give, thanks to the command line, the number of access points I want to emulate. So, for example, default is 10, and I create the 10 access points with different channels, with different SSID, with different BSSID, with coherent and consistent sequence number, consistent BSS timestamp, consistent target parameters, with randomly chosen target parameters in order to choose between open, web, WPA, RSN, TKIP, AES, AEP authentication methods, and so on, random BG cards. It's only filling some fields in target parameters. It's really basic. It's filling some fields in beacon frames and progress frames and sending them.
My question was, would an attacker be able to tell by analyzing the traffic that, here's the real IP, because I see a lot more stuff on the wire, and there's really no traffic associated with these?
Yeah, it should be very easy to detect, in fact, that these access points are not access points because it is only beacons and probe response. They will not answer to authentication, to association, etc. That is very easy. It is only to fool novice wire drivers and to fill all the nest numbers or Kismet or any sniffer with fake data and to test wireless ideas.
If you are just using like a basic stumbler, there is no way to detect, no easy way to detect the real network and the wrong network. If you want to associate to the network and try to connect and try to do things, of course, this is just fake access point. We could do more. We could simulate a real access point, but it's just very quick and ugly coding and very short proof of concept.
It's very important to make the difference between ROG, okay, fake, and virtual. And this is not a virtual access point. It is only a fake that is simulated only with some limited capabilities, that is to say beacon and probe response, nothing else.
Okay, maybe we can switch to the next tool, and we will try to find some time at the end of the presentation because we still have 2 tools to show. Okay, the next tool is called Raw Glue AP, so Raw Glue Access Point. You want to present? Yeah.
In fact, it is there is a big issue by a ROG on fake access point. That is to say, the issue is that often the weakest link is the client link. That is to say, when you are seeking some wireless networks, you associate to wireless access points. And we have some capabilities in wireless IDS, IPS in order to prevent the wireless clients from associating to rogue access points. So thanks to the authentication and the association frames, for example. So we try to evaluate another option in order to make a kind of quarantine area in order to catch the wireless clients that are currently scanning for non-authorized ESSID or null SSID, for example, or anything else. It could be tuned in the tool. It is a proof of concept tool, and it is based on the idea of Dino and Shane. We presented, I think it was at ConseQuest last year or in 2005, when they modified the driver Butti WiFi in order to populate ESSID and to catch wireless clients. But we used the same concept in a different method, that is to say using it in monitor mode and raw injection and not directly in the driver. That is to say, we wanted to have 2 aspects. The first one is to evaluate the possibility of making a virtual quarantine area, and we will talk about this later, and to eventually implement it in a wireless IPS appliance that is running in one chipset with monitor mode and raw injection. So, in fact, it is a quite more enhanced than the raw fake access point, because we create a virtual access point that's trying to catch probe request, authentication request, association request, and data frames. What is the process to discover new networks, new wireless networks? Usually some null probe requests are caught in order to deal with clients with automatic association to any SSID. That is to say, when a null probe request is sent, you send back a probe response with an SSID, and then the wireless client tries to authenticate himself to the virtual access point and then to associate itself to the virtual access point. So we send back probe response. And another option is for clients that are trying to associate themselves to preferred networks, that is to say your home, your wireless hotspot, which is generally used in open mode. So we send back the probe response with BSSID and ask ESSID. And then when the process is okay, the client tries to authenticate itself to the virtual access point. So we catch the authentication request. We must acknowledge this authentication frame and send back an authentication response with successful code. And then, if it is successful, the client tries to associate itself to the BSSID virtual access point and to the ESSID that was asked. That is to say, its preferred network. And we must acknowledge this and send back an association response. Okay, successful. This is the concept. So, it was not really tested. We tried to evaluate this. It worked on my laptop yesterday and this morning with some very specific configurations. So I hope it will work again now. As always, it's proof of concept code, so it's monitoring non-threaded answer. Very bad. Perhaps some small demonstration before, and then we will speak about this. We try to switch it. So we switch on the channel 1 in order to we put the wireless card. This is PRIMS 54 wireless card, and we make the IW config mode monitor channel 1 in order to switch on channel 1. We use the tool in a simple command line interface in order to catch wireless clients that are scanning. And perhaps it should be okay. So we have some probe request with SSID, new SSID. So at this time we send back. So I don't know if there is some people with this MAC address. Is there any people knowing this MAC address here? It seems to be code. That is to say, there was, if I come back to the, in fact, it was seeking some wireless ESSID and trying to authenticate itself to my MAC address, which is a virtual access point. That is to say, all is performed in monitor mode with raw injection. This is not a wireless card in master mode. And I sent back some authentication response because there are some issues with acknowledgement of authentication and association frames. Sometimes there are retries and so on. And then at a certain time, the acknowledge was already accepted by the wireless client. And then it passed to the association process in order to associate itself to the virtual access point. And also, there were some retries in order to associate. And then it is considered as cooked because there was some data in order to send a DHCP request, for example, etc. So it seemed to work. Sometimes it does not really work because it's very difficult to acknowledge the wireless frame very fast. So I can make a little demonstration with we have a NoSTAPI card. So I can put any SSID. And we can I don't think it works. Yeah, now it works.
So here,
So
we turn on another Wi-Fi card. We try to associate to a network A, and you can see here in the command that we are associated to an access point 30. I can read it from here, which is the MAC address of our glue AP. So we just get caught and associate to this fake access point, virtual access point.
I haven't any wireless card which is in monitor mode. I only have the ETH1 which is in monitor mode.
We need to switch to the last tool because we just have like 5 minutes left.
Very fast.
Very fast. Maybe one very quickly. So the last tool is some raw covered channel. I think that you all know what is a covered channel. The idea is to send information writing between the line, so trying to hide communication. And with Wi-Fi, there are plenty of things that can be done if you want to send information using covered channel. So, as I said, with 802.11, this can be performed by many ways. And of course, we're going to talk about raw injection again. The idea is to, for example, to use some frames that are not considered as malicious, or even some frames that are not very easy to detect. For example, some frames that are not reported by some driver, for example. And the idea here is, for example, to use an hack frame, which are quite cool because, for example, with
in fact, some drivers do not give back the hack frames, so it could be very interesting when you are encoding a covered channel in order to use some frames that are usually not analyzed by wireless IDS, for example. So how it works, it basically sends some hacks and encode the covered channel in hack. Which is this proof of concept really basic, that it is not really optimized. We use a magic number, we encode the channel in 1 byte, and we send the information and decode it at the end back at the end. So of course, sure, some hack frames can be missed. There is no reliable wireless medium, no enhanced features, etc.
There are many possible enhancements. Here, just a proof of concept, but we can use the tool and code, for example, remote shell, file transfer, whatever you want. There are many things that can be done if we want to go further. Right now, the tool just uses regular hack frames, but we could imagine to use, for example, FCS invalid frame, which means wrong checksum frames. Yeah. This is a bit tricky because we need to bypass all the driver in order to be able to send malformed wrong FCS frames. But for example, using those kind of techniques, in this case, it will be very, very difficult to detect because no tools will be able to monitor. Well, it doesn't make sense to monitor bad FCS frame because there are plenty of them on Wi-Fi networks. And if you start to monitor those kind of frames, the job is huge. So, live demo very quickly. So we could do the demo on the same laptop, but for a covered channel, it's better to use 2 different laptops to show you that we are really able to communicate between 2 laptops. On the same laptop, it could be one. So I just need to reboot.
Bytes of the receiver address for the magic number, and then just uses 1 byte
Yeah.
And the other 3 bytes are?
Set to 0. Usually, this kind of frames like only use you should be able to encode it in duration value, for example, but it could be detected by any wireless IDS looking at duration value, high duration value especially. You could encode it in the tail of the hack frame, but it should be also detected by any wireless IDS that are looking at the length of an hack frame. The main option should be to encode it in byte frames in order to be more specific, for example. Yeah.
It's very easy to tell you cross cards to transmit invalid SCSs too.
Yeah.
So that would be particularly scary.
Serveur 1. D'accord, full channel 1.
Quel channel?
Channel 1.
So you can see that very basic tool, but I start to receive information that is sent here, and
So it is truncated to 32 bytes, and we send back the channel by several hack frames.
vas-y. Vas-y, balance des trucs. Vas-y. So I need to find a hack somewhere.
Magic
Wow.
number is 6666, I think.
I think we are running out of time, so if you have any question, anyway, we will be here till tomorrow, and we will probably be at 4 tonight. So if you have any question, the URL, yes, that's a good point. The URL, here we go.
There is only the first tool, which is released at this time. It is a version that only implement beacon mode, and all this the tool will be released in this
URL. So the URL is http rfakeap.tuxfamily.org, and you will be able to find the first tool, so the raw fake AP, and hopefully if we get network access, which we should, maybe by tomorrow or in the beginning of the week.
Yeah, sure.
So thank you very much for your attention.
Thank you.
Thank you. I don't think so.
Hi, how are you? Great presentation.
The main point is that I think that we need to recode the whole thing, because right now, as you probably understand, we need to send by ourselves the frame, and we have a very, very short period of time.